All right, guys, when we left yesterday, you should have, I asked that you at least try on the last 4 examples, well, actually 3 because we did the first one together, just to try to name the transformation. So what is our graph going to look like? So for example, in the first one, we picked out a vertical reflection, which tells me my graph isn't going to open up, it's going to open down. And then we know that it's shifted over to the left. So before I even graph, I know what the graph should look like. So I want you to pick those out. Now today what we're going to do, because I know everybody doesn't have a graphing calculator to take home. Now we're going to use the technology to get us a couple values, a couple ordered pairs, so we can sketch that graph, and then we'll talk domain and range. So let's look at the first one. We have -3, and then x plus 7 in the exponent. Whoa. Not sure why mine's giant. Sorry, guys. I got to restart mine up here. So go ahead and hit your y equals. Oh. Mine went weird. Sorry, guys. It was right this. Calculator's better. So let's go to our y equals. Go to our y equals in that very, very upper left-hand corner, highlighted red on my screen. Clear out whatever you have in there. And let's enter in our first one. We had -3. Remember, guys, the negative sign is down by the enter key. There's a difference between negative and subtraction on these calculators. It's very picky. So we have -3. And then the x plus 7 is all part of the exponent. So most of you have kind of one of the older calculators, the 83s. So you need to make sure you put parentheses around your exponent. So negative, using the negative sign down by the enter key. And then the exponent is x plus 7. To make sure the calculator knows that the plus 7 goes with the exponent also, you need to put some parentheses around it. Okay. Now, our windows should all be okay from yesterday. But just do a quick check, especially if you're borrowing a calculator or maybe you didn't have yours yesterday. Just press the window real quick. Make sure the x min and max are at our -10, +10, and the y min, y max are there also. Again, especially if you're borrowing one of my calculators, people use them in 3 other classes, so they might have just kind of changed things up just for the heck of it, I guess. So just double check your window. Go ahead and press graph. We said our graph should be flipped upside down and shifted to the left. Opens down, and it's definitely over on the left. So now, how do we get that onto our paper and get a good sketch? Second graph gives us our table. Now, where my table's at right now, I have a bunch of just giant values. So use your arrow key and let's see if we can find something that's a little more manageable. And as I scroll, once I hit -7, -7, -1, easy to graph, -6, -3, -5, -9. So as your graph moves around, you have to do some scrolling on your table. If it goes to the left 7, -7 is left 7. So it makes sense to us that we should have to go to where x is -7. So I'm going to do -7, -1, -6, -3, and -5, -9. That's what I'm going to put on my sheet. So let's do that real quick. Maybe. All right, so -7, -1, -6, -3, -5, -9. Okay, so 1, 2, 3, 4, 5, 6, 7, -1, -6, -3, and -5, -9. Now, we didn't move our graph up or down at all. So that magic line, that imaginary line that we're not going to touch or cross is still at 0. The only time that your line that you're not going to touch or cross changes from 0 is if you've moved your graph up or down. So we're still not going to touch or cross 0. And you can even see that if you look at the graph on your calculator. You see it gets really close to that x-axis, but it doesn't touch or cross it. So the idea with picking out those transformations, I know my graph should vertically reflect. So flips from up to down. And it should be on the left side of my graph before I do anything else. So then when I graph it on the calculator, some of us I know are still getting used to entering things incorrectly. You know what the graph should look like. So if you enter the equation in your calculator, you press graph, and you're like, wait, mine's not over on the left. You didn't enter something in right. Okay, so it's a little double check for yourself as well. Domain, always, always going to be all real numbers for us. We can put whatever we want in for x. We don't have anything goofy like trying to divide by 0 and getting an error message. Now the range deals with our outputs. That imaginary line that we're not going to touch or cross is still at 0 because I didn't move my graph up or down. Now my graph though, is my graph up above 0 or down below? It's below, so what are we going to put? We're going to go with the less than. Absolutely. All right, so that one question, guys, that just took us, and talking through it together, it just took us about 3 or 4 minutes. Not a ton of time for one question, and we get a nice graph. We've got domain and range. We've got our transformations. As you do these on your own, and you don't have me talking up here, they're going to start going quicker for you. That's why we're using the technology. All right, so let's look at the second one. Let's check your transformations. Let's see how you did. We have a 3 out front in front of our base. So as we look up at our little organizer up above, our A value is bigger than 1. It's going to make our graph go up faster. It's a vertical stretch. So this should be a vertical stretch, which means our graph is going to go up faster. It doesn't move up or down. The values in this case are just tripling, so it's going to go up faster. And then the -8 off the end. The -8's not part of the exponent, so the -8 is like our k up here. Minus k, we're going to go down. We're going to go down 8. So our graph should be moved down 8, and it should go up faster. So it's going to look like it kind of hugs that y-axis a little more closely. Let's get some values. Once you guys really get used to entering these things in the calculator, you'll be like, Miss Callie, this is the best thing for graphing ever. All right, let's clear it out. And we need a 3. Whoa, not a 33. Ooh. 3 parentheses 2 to the x. And then make sure, if you have a calculator like mine, you need to arrow to the right to get out of the exponent before you do your -8. So if you have one of the newer calculators, you have to make sure you arrow to the right to get out of the exponent. Once you have that, guys, go ahead and press graph. You don't have to wait for me. If you're like, Miss Callie, I can rock this. Go ahead, get your table, sketch yourself a graph. If we graph it, whoops, we said it should be shifted down 8, and it's going to go up pretty fast. That graph is it's really kind of hugging close to that y-axis. It's not as wide as what it would be without that 3 in the front. So it's definitely shifted down, and it's going up faster. Sometimes the up faster part's a little bit harder to tell. But let's go to our table. Let's see if we can find some good values to graph. So second graph. And I'm going to scroll down just a little bit. Actually, I really don't need to. I guess I've got some good ones right there. So I'm going to go with 0, -5. I'm going to go 0, -5, 1, -2, and I'm going to go 2, 4. I'm going to go with those. Those look awesome. Those look easy to graph. So 0, -5, 1, -2, and 2, 4. Now we said we went down 8, so that imaginary line that we're not going to touch or cross is where? Where's it at? If we move down 8, where's our imaginary line at? It's down at -8, yeah. So at -8, I like to draw the line in. You guys don't necessarily have to because there's already a line on the graph there for -8. And we have 0, -5, 1, -2, and 2, 1, 2, 3, 4. We're going to get close to -8, not touch or cross it. And we're just going to go through those other 3 points that we found. So our graph did exactly what we said it would do. It's definitely down 8. And it's going up faster. I know it's a little bit tougher to tell, but our points are getting a little more spread out. And it looks like it's a little closer to that y-axis. Domain, guys, don't even give it a second thought. When we're working with exponentials, we can put whatever we want in for that x. We're not going to have something weird like dividing by 0 or trying to take the square root of a negative. That doesn't work either. Now, the range is where we have to focus, though. That's dealing with our y values. The imaginary line that I can't touch or cross is at -8. Is my graph above that -8 line or is it below? It's above, so we're going to put greater than. Yeah. It's above, so we're going to put greater than. On number 3, guys, I just want to make sure you have your transformations right. Then I want to give you a chance to enter in number 3 and get yourself a table of values before we go through it together. But I want to make sure you're okay on your transformations first. Now, with number 3, I had a couple people ask me yesterday. Number 3 can be a little tricky because that -2 is going to do 2 different things for us. And a couple people did ask me about this. The negative sign in front of my base, we saw it in example 1. This is going to cause my graph to vertically reflect. It's going to go from up, right side up to upside down. So it's going to go from right side up to upside down. And I know it's going to be tough. We have to kind of pick this apart. Then the 2. The 2 is bigger than 1. The 2 is greater than 1. So it's going to cause my graph to vertically stretch also. So that -2 is kind of a 2 for 1. The negative sign causes us to go from right side up to flip upside down. And then the 2 is bigger than 1. So we're going to also stretch. Our values are going to, in this case, they're going to decrease faster because we're going to flip upside down. In the exponent, we're subtracting. So we're going to go to the right. The +7, that's totally at the end. It's a big 7, not part of the exponent. It's going to make our graph go up. Don't worry about it. If you're like, Miss Golly, I just put the reflection part. I didn't get the stretch. That's okay. That's why we're talking about it. Okay? I didn't expect that you would know that that's going to be kind of a 2 for 1. So what I want you to do, enter that into your calculator. Please keep in mind, put parentheses around that exponent. Get yourself some values and see if you're right. We know that your graph should be flipped upside down. It should be over to the right and up 7. So if you're like, oh, I'm not sure if I enter this in right, that's what your graph should look like. It should be over to the right, it should be up 7, and it should be flipped upside down. So try it out in your calculator. See if you can enter it in. If you want me to check your screen before you grab your table, I can do that, no problem. Let me know. I have a lot of people with ordered pairs out there. Somebody throw me a couple that work really nice. -5. -5, 7? Oh, I don't know if that works on this graph. -5, 7 is going to be over on the left. 5 and 5. 5 and 5? And What else works? 6 and 1. And then the next nice one is at a negative 11, right? That doesn't fit on our graph. As long as you can get 2 points, that's okay. We'll go with 2 points. Now, where's my imaginary line at that we're not going to touch or cross? It's up at 7. 1, 2, 3, 4, 5, 6, 7. There it is. 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 6, 1. It's going to get close to that 7 line. And then it's going to get further away from that 7 line. 2 points, guys, and we have a beautiful sketch. 2 points and we have a beautiful sketch. Now, I can't have something, guys. Somebody had said negative 5, 7. My graph can't equal 7. 7's my magic number that we're not going to get to it and we're not going to go above it. All right, domain, what do we think? Domain's always going to be all reals. That goofy capital looking art I keep throwing out there. And our range is always y. The value we're not going to touch or cross, 7. Are we above the 7 or below? Below. We're always below, so it's going to be a less than. Let's talk transformations in 4, and then I want to give you guys a chance again. Try the calculators yourself. All right, the number in front of my base, that's our A in our little summary at the top. It's smaller than 1. It's smaller than 1. So we're going to have a vertical. If you want to put compression, or if you like the word shrink, we use both of those. It doesn't matter, whichever one you want. Compression or shrink, up to you. Remember, when we're multiplying by that number smaller than 1, our graph is just going to go up a little more slowly. So sometimes that one's tough to see as a transformation. It's just making our graph go up more slowly. The plus 2 is not part of the exponent. It's just tacked on to the end. Sometimes I'll phrase it as, hey, it's a big 2, not a little 2, so it's not an exponent. That big 2 is going to make us go up 2. Now, as soon as you have an up or down, guys, if you want to, I have some people that will just go ahead and put their imaginary line in. The only time that line is going to shift off of 0 is if you move the graph up or down. Nothing else is going to make that line move. Now, when you enter this into your calculator, if you have one of mine, which is one of the older ones, when you put your fraction in, you have to put it in parentheses. Oh, let me scoot that over a bit here. If you have one of the older calculators, you have to do parentheses. Oh, I didn't do that any better. And you've got a plus 2. So you need to put parentheses around that first fraction. Put parentheses around your base number so it multiplies correctly. Now, with this particular one, you may or may not get pretty numbers. Yesterday, when we graphed one with 1/3, we had to graph some decimals. So if that's the case, just pick what decimals you think you can handle best and go with it. So go ahead, guys. Put in your calculator. You know that it should be shifted up to, and it's going to look a little bit wider. Other than that, we don't have any other changes. All right, guys, what were those great values you told me that worked out? 1, 4, 2, 8. Is that all that fits? Okay. So 1, 1, 2, 3, 4, 2, 1, 2, 3, 4, 5, 6, 7, 8. We're going to get close to 2, not touch it, cross it. And then we're going to rise up. Domain. Domain should be some of the easiest points ever when we test on this unit. It's not going to change. For the range, it's always y. My imaginary line I can't touch or cross is at 2. Is my graph greater than 2 or less than 2? It's greater because it's up above. So what you guys have now, in particular on this last sheet, you have your guide at the top. You have your transformations guide. What number is going to do what depending upon where it's at in the equation. And then you have 4 examples that demonstrate every possible type of transformation we talked about. Okay, so that back page is going to be a huge resource when you guys go to start your practice. Now, speaking of practice, I know not everybody has graphing calculators to take home. So, give me just a minute here. All right, so for your assignment, if you do not have a graphing calculator, you need to make sure you complete Part C on 13 through 16 before you leave today. Part C is going to be the table part. The table part is what you need the calculator for. And it shouldn't take you very long because there's only 4 questions there. If you have your own graphing calculator, you can work through the questions however you'd like. Answer key will be on the board. It's already up there. I'll put it on its learning before I leave today. I won't collect this assignment until Tuesday, but we are going to move on to our next thing Monday. And we should have some work time Monday. So, like, Miss Guy, what if I have questions? This is due Tuesday. We should have some work time on Monday for you. Okay? So let me get that assignment out to you. And then we'll talk